So in this session, we'll discuss the questions related to particle physics. Question 5. Which row of the table shows a quark structures of meson and its anti-meson? Yes, what could be the answer? A meson and anti-meson. Keep in mind, mesons are combination of quark and anti-quark. So what could be the right answer here? This is the right answer because you can see first to be a meson, it should be quark and anti-quark, means two quarks are there, and the condition one of them is quark, another one is anti-quark. So C and D, as you can see, in option C and option D, they have three quarks, so it cannot be meson. Then you are left with two of the option, both, but anti-meson, which is correct because if it is up is there, if anti-up is there, anti-particle will be up, and if down is there, anti-particle will be anti-down. So A will be the right answer. But you can see here in this one, actually it's the same. Mesons are given in both options. There is no anti-particle. If we change the position of the particle, that does not change the particle. Like first we wrote up and then anti-down, and then anti-down and up. Does not make difference to the type of particle. A particle has a mass of 3.4 giga electron volt per c square. Which of the following give the mass of the particle in kilogram? So you have to convert them into kilogram. Look, basically, you will use the formula E is equals to mc square. So in this case, what's the meaning of particle which is having a mass of 3.4 giga electron volt per c square? Means it will produce this much energy when a particle, the matter changes into energy. This is the equivalent energy which is released. So what could be the right answer for question 6? Question 6, what could be the answer? Yeah, that's correct. D is the right answer because we want to convert this into mass. So we have the formula E is equals to mc square, or m is equals to E divided by m is equals to, or E divided by c square is equals to m. E is the energy, but that energy should be in joules. If this is a mass which is equivalent to energy release, that's 3.4 giga electron volt. So first we'll convert this into electron volt. That is equals to 3.4 into 10 to the power 9 electron volt. But to convert electron volt into joule, we'll multiply by 1.6 into 10 to the power minus 19. So that will convert this energy into joule. And c is the speed of a light, so speed of a light square will divide by that. That's why D is the correct answer. Is it clear why D is the right answer for this question? In a science fiction film, a spaceship has engine that uses antimatter. A helium and antihelium are collide in the engine. Describe the particle making up the helium atom in terms of standard quark and lepton model. So in terms of standard quark and lepton model, what are the particles present in helium? So as we know, helium contains 2 protons, 2 neutrons, and 2 electrons are there. So we will just identify the particle. So electron, which is a lepton, then proton, which will be baryon, and neutron also baryon. And what is baryon? Baryon consists of 3 quarks. A proton and neutron made up of 3 quarks. Calculate the energy released when an atom of a helium annihilate with the atom of calculate energy released when an atom of helium annihilate an atom of anti-helium. The mass of the helium is 6.4. So basically, when matter and antimatter combine together, that annihilate or release energy. So we have to calculate how much energy is released. So we have the simple formula E is equals to mc square, which shows how much really energy released. But what mass I will substitute here, because the mass of the helium, which is given 6.64 into 10 to the power minus 24, and mass of anti-helium is also 6.64 into 10 to the power minus 24. So both have the same mass. The only difference will be the spin and the charge. So when they combine with each other, they release energy and conservation of momentum. So it released 2 photons. But they did not ask calculate energy of the each photon. They asked how much energy is released, total energy. So we have the mass, the sum of the masses, that the total combined mass, and speed of a light, which is 3 exponent 8. So 3 exponent 8 square multiplied by the sum or the product of the two masses will get the energy, and that will be in joules. Is it clear discussion how we calculate the energy released when this annihilation occur? If they ask the same question was there, calculate energy of each photon, because it is releasing 2 photons. So the total energy which is released should be divided by 2. Only the particle physics question I will discuss. Yes, the reason why in annihilation always 2 photons are released, why not 1? Because the momentum should be conserved. So example, when in this example, when helium and anti-helium join together, they convert into energy, means photon. But because the momentum should be conserved, as a particle and antiparticle move towards each other, collide with each other, so initial momentum is 0. So if initial momentum is 0, what should be the final momentum? The final momentum should also be 0. So how the final momentum can be 0? If I say if there is only 1 photon is released, then if 1 photon is released, final momentum cannot be 0. So there should be a another photon in opposite direction to conserve the momentum. This one is January 2018. Which of the following is not a lepton? Question number 2. Which of the following is not a lepton? Leptons are the fundamental particles experiencing weak nuclear force. Positron is antiparticle of electron. So if an electron is a lepton, positron is also a lepton. Both are leptons, but one is particle, another one is antiparticle. Neutrinos, electron neutrinos, tau neutrinos, these are also leptons. Pion is a meson, which is a combination of quark and antiquark. So the correct answer was C. Pion is a meson. A baryon and a meson are type of particle that consist of quarks. Which row of the table shows a possible quark composition for a baryon and for a meson? Meson consists of two quarks. One should be particle, like one should be quark, another one should be antiquark. Yeah, D is the right answer here, because the only option in a meson part which contain quark and antiquark is D. Others like this cannot be meson. You're left with two quarks here, two options B and D, but only one which is having quark and antiquark is D. Okay, in this question, they mention a particle which is kaon, particle decay produce a pion, a muon, and a neutrino. Complete a nuclear equation to show that the charges on the particle. So the charges on the particle, because overall, as we can see, this is electron neutrino, tau neutrino, and muon neutrino. All their charge is 0. And what is the charge of muon? Muon is a lepton. So for a lepton, as we know, like electron, tau, and muon, which are leptons, so their charge is negative, minus. And because the conservation of the charge should be there, the charge should be conserved. So if this is minus, what should be the charge here for pi? So this will be pi plus. Is it clear how we worked out the charge? Because the anti-electron here, anti-muon neutrino is given off muon neutrino, anti-muon neutrino, both have charge 0. But what is the difference here? Because the initial charge is 0, so final should also be 0. If muon charge is -1, what should be the charge of pi? It should be plus, so that there's a conservation of the charge. Ordinary matter is made up of proton, neutron, and electron. And at the time they were discovered, these particles were not thought to be made up of any other particle. Like when there was a discovery of the electron, proton, neutron, so it was believed that these are the fundamental particles, that they are not divided into further subatomic particles. Explain how a proton, neutron, electron are described in the current standard model of a matter. So how we explain what is a proton, what is electron, and what is neutron in terms of current standard model. So what we say electron is a fundamental particle. So we can say electron is a fundamental particle. If we say it's a fundamental, it means it cannot be further broken down into more particles, or electron is not made for any other particles or made up of any other particle. Where proton and neutrons are not fundamental, are not the fundamental particles. And what are they? Proton and electrons are leptons. And what are proton and neutron? Because they consist of three quarks, so we call baryon, or consist of three quarks. Is it clear? Hadron means combination of when meson and baryon, collectively known as hadrons. When I use the term hadron, what is the meaning of hadron? Hadron means meson and baryon collectively. So baryon means only three quarks are there, where meson means two quarks, one should be particle, another one should be antiparticle. And collectively they are known as baryon. Okay, in this question, when an X-ray photon interact with an atomic nucleus, a pair production occurs. What's the meaning of pair production? It means particle and antiparticle are produced. In a pair production, a photon energy produces an electron and positron. Electron is a particle, positron is antiparticle or antilepton. For this to occur, the wavelength of X-ray photon must be less than the certain value. Wavelength is less or frequency should be high, so energy will be high. Show that the maximum wavelength of X-ray photon is about 1 exponent minus 12 meter. So first, we should know how much energy is released, how much energy is required to produce these particle and antiparticle. And our assumption in practical, you need more energy, but your assumption is just to produce a particle. So just to produce a proton and antiproton, how much energy I need is equals to mc square. M is the mass, the total mass which I want to produce, because I want to produce an electron and positron. Mass of electron is 9.11 into 10 to the power minus 31 kilogram, and mass of positron will also be same. So total mass will be twice multiplied by speed of a light, which is 3 into 10 to the power 8. So when I solve, I'll get E energy. And after getting this energy in joules, I need a wavelength, because the question is not about energy, it's about wavelength. So I'll use the formula E is equals to hc over lambda. I know how much energy I need for a photon. The Planck constant 6.64 exponent minus 34. Speed of a light, which is 3 exponent 8. So I can find the wavelength which is required to produce this pair of electron and positron. Is it clear, this part? Then for a part, second part, state why two electrons cannot be produced in a pair production. Yeah, what's the reason? Look, what what might be a reason of 1 mark? Like a photon is generating electron and positron. Why it is not producing two positrons? What's the reason? Or why it is not producing two electrons? This is what is happening. But the question is why electrons are not produced, that it should produce two electrons. So if it produces two electrons, then what will happen? The charge will not be conserved to balance the charge. Not about the same particles, about to balance the charge, because initially photon is zero. That there's no net charge on photon. So final charge should also be zero. That's why for a conservation of the charge, due to conservation of the charge, it cannot produce two electrons. Otherwise, because initial charge, the initial charge was zero. So if initial charge is zero, the final charge should also be zero. In the next part, after a production, the positron and electron moves in different direction. Suggest what happened to electron and positron after this. So why they move in opposite direction? What's the reason? And like they're moving in opposite direction, but the question is what will happen? So a photon gives electron and positron. The question is not why it is produced. The question is what will happen after some time. Yeah, they're moving in opposite direction to conserve the momentum. But the question is, if you check the question, it is after a production, positron and electron move in opposite or different directions. Suggest what happened to electron and positron after this. Means they are moving in opposite direction, they mention, and that's due to conservation of momentum. But that's not the question. The question is, what will happen after this? Like this, these particles are moving in opposite direction. So what could happen? Yeah, they can interact with other particles, or they can annihilate with other electron. So these are the possibilities when electron and positrons are moving in opposite direction. So annihilation might occur with another particle, or they collide with other particles, lose their energy. Question 1, what could be the answer for question 1? Which of the following is not a fundamental particle? So C is not a fundamental particle. Pion is a meson. Electron, fundamental. Lepton, neutrino, fundamental. Lepton, quark, also fundamental. And there are types of quarks, like 6 quarks are there. It can be any one of them. Kaon decay into pion and 2 leptons. Which of the following decay is possible? Question 6. What could be the answer for question 6? It's easy to recognize the so first thing, when you check the conservation of the charge, when you check the conservation of the charge, this one charge is conserved, -1, but -2, so charge is not conserved. +1, +1, charge is conserved. -1, -1, charge is conserved. Then you have to check the lepton number. You have to check the lepton number as well as baryon number. So when you check or work out the possible decay, because a kaon decay into pion, so there is a pion and 2 leptons are there. So pion and 2 leptons are given. So first you check the conservation of, you have to check, go through all, like check the conservation of the charge. So when you check the conservation of the charge for B, why B cannot be? Because why B is not a right answer, because when you check the B, the charge is not conserved. Then when you check for C, why? Because there are neutrinos for muon. When you check C, why? Because the neutrinos for muon are there. See, this is which muon is which one which neutrino is given off. If this was muon, then it should be muon neutrino, not the neutrino of electron. If it is electron, then it should be electron neutrino or anti-electron neutrino, depending on the question. Same thing, if it is muon, then it should be, if muon was there, then the particle associated, it should be muon neutrino. Same thing when you check the D. So the neutrino, as you can see for D as well, it's electron, so it should be electron neutrino, not muon neutrino. So this is the right one because muon is there and muon neutrino is also given off. So first check the conservation of the charge, then the associated particle, lepton number, baryon number, you can also check. In 2015, scientists at CERN announced the discovery of a particle known as pentaquark. Pentaquark means like 5 quarks are there. At this time, the pentaquark structure had not been determined, and it was suggested that might have a 5 quarks tightly bonded at a single particle or a meson baryon molecule. Why we call meson baryon molecule? Because meson means quark and antiquark, and baryon means 3 quarks. So it's like a molecule of meson and baryon. So the table shows the charge. The table shows the charges of the 6 types of quarks. You can see the charges are given. For positive degrees, +2/3, and for negative, it's -1/3. Complete the following diagram to show how the 5 quarks shown in the single particle model could be arranged as a meson baryon molecule. And the meson should have a charge 0, whereas baryon should have a charge plus. So what will, like plus elect or 1 coulomb, you can not one, like 1.6 exponent -19 coulomb, or equal to equivalent to electron, because this E refers to 2/3 times 1.6 exponent -19. So what could be the composition of a baryon from by using the above model, which is having a pentaquark? So what could be a baryon which is having a charge +1? A baryon which is having a charge +1. So it can be up, 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 down. Okay. If you select up, up, down, okay, as you mentioned, you select up, up, down. So up, up, and down. Then this will be C, and but this will be highly unstable meson. You know why it's highly unstable? Because the combination of quark and anti-quark. So if quark and anti-quarks are there and same identical, like if charm particle anti-charm is there, so what will happen? This might annihilate, does not remain for a longer period of a time. A very short half-life will be there for this particle. So to be more stable, what else we can select? A combination. So it can be up, charm. It is not necessary that meson should have the same antiparticle of that. Like if it is charm, then anti-charm. No, a meson can have up and anti-charm. It can be any other particle. So if I select up and anti-charm, so I select up and anti-charm, then it will be up, charm, and down. So a meson is a combination of a quark and anti-quark, but it does not mean that like if I have charm, then it should be anti-charm. This it can be anti-charm and down. It can be an anti-charm, but it will be a short-lived, remain for a short time period. Pentaquark has a mass of 4.38 giga electron volt per c square. Calculate the mass in kilograms. So same way, first what you will do, you will convert this into energy, like 4.38 giga means 10 power 9 electron volt. That's the equivalent energy it will release, but you will convert this electron volt into joules. So you will multiply 4.38 into 10 power 9 multiplied by 1.6 into 10 power minus 19. So when you multiply them, you will get in joules. So after getting energy in joule, you will use the formula E is equals to mc square. When energy is in joules and speed of a light, which is constant 3 exponent 8, you can find the mass in kilogram. The pentaquark was produced in a decay of a lambda 0. So there's a particle called lambda 0, which was created after a collision between a high energy proton. Like two protons or protons are colliding, it creates a lambda 0 particle, and which result in pentaquark. In the experiment at CERN, a lambda 0 particle was made to have traveled 3.9 centimeter after its creation before decaying. The lambda 0 particle exists for 1.8 exponent minus 12 second. Use these results to calculate the value of speed and comment on your answer. Like this is a distance traveled by this. What happened? Like there are in particle accelerator at CERN, they collide protons. The collision of a proton release give another particle lambda, and this particle lambda particle move 3.9 centimeter in 1.48 exponent minus 12 second, and then it decayed. So we have to use the result value of the speed and comment on your answer. First, we'll find the speed. So speed is distance over time, but distance is given in centimeter, we'll convert into meter. So it will be centimeter into meter divided by 100. So it is 3.9. So 0.039 divided by this 1.48 into 10 to the power minus 12. What's the answer when you divide this? Distance over time. Can you mention a speed? (0.039) divided by 1.48 exponent minus 12. What's the value for the speed? So 2.63 into 10 to the power 10. You can see what is the speed of a light. Speed of a light is 3 into 10 to the power 8 meter per second. And this particle is traveling more than the speed of the light. So what happened? It shows that this particle is traveling more than the speed of the light. Until now, we don't have any particle which travel more than the speed of the light. So this is impossible that the particle was there or moved this distance in a short time, or due to a relativistic effect apply. Relativistic effect is, what's the meaning of relativistic effect? When the particle tend to move close to speed of light. Like example, I'm just taking a crude example. Say this particle is 2 kilograms. If the particle move close to the speed of the light, what is the meaning of the relativistic effect? If it is traveling closer to speed of a light or same as speed of a light, the mass of the particle no longer remain constant. The mass of the particle increases. We call this effect as relativistic effect. And what is the reason why the mass increase? That is explained by Higgs boson, that when the particle moving with the speed of the light or close to speed of a light, they gain the particle bosons or Higgs boson. That's why the mass will increase. So if the mass increase, the speed of the particle will start to decrease. It cannot have a same acceleration because the mass is not constant. So you will comment here, like you will mention, work out the speed. 1 mark is for mentioning, like finding the speed using a formula. Second is for the value of speed. And then third one, you will compare with the speed of a light, and you can mention relativistic effect specific. Like example, you will mention the mass of the particle will no longer remain constant or relativistic effect will take place. Is it clear? This part. Then experiments involve a collision of proton. Why high energy are required for the experiment? Look, we are producing a particle. We are producing a massive particle. So when the kinetic energy is more, so it can produce a higher or greater number of the particles. And protons are light charges, so we have to overcome the electrostatic repulsion as well. So reason one is to produce a high mass particle, we need high kinetic. Second is overcome the electrostatic repulsion because the light charges repel each other.